Your front end calls your backend service for any request that needs to be showed on its web. But have you ever thought if there are a lot of requests coming from your front end to your backend service? Will your backend service be in a position to handle all those? And what if your backend service is down? It will become a single point of failure. To handle such situations, generally what people do is either they increase the CPU and RAM of that service, which is horizontal scaling, or they'll simply clone that service and have multiple instances, which is vertical scaling. But then the problem is your front end will still call the same instance every time it needs to call the backend service. In this scenario, even though you are having a clone of your service, you are not actually using it. This is where load balancer comes into picture. If you keep a load balancer in between your front end and the backend services, front end will call your load balancer. Load balancer takes the responsibility of distributing the requests coming from the client between the servers. How does the load balancer know to which server the request needs to be routed? It uses multiple algorithms. Some of them are round robin, least connections, and least frequently used servers. With this load balancer, the two problems which we discussed in the beginning were resolved. One is it won't be a single point of failure anytime, and then if there is lot of load on the servers, it will route the requests. What if the load balancer itself fails? Then also it will become a single point of failure, right? Which is why most of the times even the load balancers will also work in either active active or active passive clusters.